redo this. What are the three trig ratios? Well, it's sine, cosine, tangent. What's the ratio for sine? So sine of angle x equals opposite over hypotenuse. What's the cosine? Cosine of angle x equals adjacent over hypotenuse. Tangent of angle x equals opposite over adjacent. How do you determine if the side is a hypotenuse? Well, on a 90-degree triangle, right? So locate your 90-degree triangle, and the side that's opposite, or the longest side, I should say, opposite 90-degree angle is your hypotenuse, and that's how you locate your hypotenuse always. Right? Hypotenuse. What determines if the side is opposite or adjacent? Well, it depends on the angle, right? So again, let's draw another triangle here. And this is, let's talk about this angle. Let's call it angle X for now. Well, opposite of angle X would be this guy, right? Opposite. The hypotenuse is the side opposite the 90-degree angle, and obviously the adjacent would be this side next to angle in particular that we're referring to. Okay, what the SOHCAHTOA stands for? Just a little gimmick, right, for you to remember that sine is opposite of our hypotenuse, cosine is adjacent of our hypotenuse, and tangent is opposite of our adjacent. What's the difference in finding a side as opposed to finding the angle? Well, the difference is that in your calculator, right, so if you're using, so to find the side, let's say a side of angle 30, you would go opposite over hypotenuse, and then, but if you find the angle, let's say you want to find this angle, you have to find the inverse function or inverse sign, so you would use this little button in your calculator. What might you do differently on the calculator to find the angle? Well, I guess I just answered that question. What's the angle of depression? Well, remember, it's all based on the horizontal line, right? So, and what's the angle of elevation? So let's talk about angle of elevation. So let's say, let me draw it out. There's a tower here, okay, and there's a point here on the ground. So the horizontal line would be this, and then if you make a line from the ground here, right, to the top of the tower, this would be your angle of elevation. But you must first establish your horizontal line because it's dependent on that. So as same thing with the depression, let's say there's an airplane here, right? So the airplane is looking on the horizon. This is the horizon for the airplane, and there's a boat here in the ocean, and it forms an angle like this, right? The angle of depression from the airplane to the boat would be this, not this, right? But based on the horizontal line. So there you go. That would be your angle of depression. Okay. How do you know the difference? Well, it depends on the word problem, right? So that's what's going to determine the angle of elevation, depression, right? So elevation, obviously, you're thinking of going up. Depression, obviously, you're thinking of going down. Okay, so just a few things. I don't think I'm going to do all because there's a lot of questions, but I'll do some. So here is, we want to find the angle, and we're given, so I think it's always nice if you start by labeling a triangle. So this is your hypotenuse, this is your opposite, right, from angle X, that's your opposite, and this is your adjacent. We're looking for the angle, and we're given, and we have information, we have the opposite and adjacent, so we're going to use tangent, right? So we're going to write tan of X, angle X, equals opposite, which is 16, over adjacent, which is 10. Now, when we want to find the angle, remember, angle X equals going to be the inverse, or 16 over 10. You can leave it, you can enter that in your calculator like that. Or if you want to change it to a decimal, that's up to you. So in your calculator, second function, the trig, and you're going to go all the way to number 6, the inverse 10, and you're going to enter 16 over 10, right? As a fraction or a decimal, however you choose it, doesn't matter. and our angle is going to be, the angle x is 57.99 degrees. There we go. Okay. Here's one finding the sine. So again, this is the hypotenuse always, right? We just write h. Hypotenuse is opposite the 90-degree angle. Now, from the perspective of angle 17, this is the opposite and this is the adjacent. So we want to find the side in this case, and we have information. We have an angle, the hypotenuse, and the adjacent, which we want to find. So the opposite doesn't really come into play. So something that uses the adjacent and the hypotenuse would be cosine. So cosine of 17 degrees is adjacent, which is x, we're trying to find, over hypotenuse, which is 9.7. Cross multiply, and we get x equals, cos of 17 times 9.7. So in your calculator, second function, trig, oops, I'm going to find, when I enter number 2, and then cosine of 17 degrees times, actually, let me enter 9.7 times second function, cosine is number 2, and 17 degrees. Enter, that's going to give us that x, the side, the adjacent side is 9.28. Not degrees, sorry, units. Okay. So these are the easy questions, I think, right? So they're pretty simple. So 3, 4, 5, 6, 7, 8. Well, you know what? I'll just work those 3. This is the hypotenuse. I'll label hypotenuse. This is the angle, so this would be the opposite. This would be the adjacent. So again, it's going to be not cosine, sine. So sine of 63 is opposite x over hypotenuse, and x equals 50 times sine of 63, and x equals 50 times of 63, which is going to give us 44.55. This is angle x, obviously opposite of angle x is 7, so that's the opposite. This is the adjacent, this is the hypotenuse. We want the angle, something that uses what do you call opposite and adjacent, and hypotenuse would be sine. So sine of angle x, right? If you have an angle, is opposite over. So what angle can that be to give a ratio of 7 over 13? Well, to find the angle, we're going to use the inverse sine. Then that's what you're going to put in your calculator. So second function, number 4, I believe, and then we enter 7 over 13, or if you want to divide that and enter the decimal, that's okay. So the degrees here is 32.58. We want to find the sine, so angle 25, sorry, this is the angle, so opposite this angle would be the opposite of angle 25 would be the opposite. This would be the adjacent, this would be the hypotenuse. So we're going to use tangent, so tan of 25 equals the opposite, which is x, over the adjacent, which is 15. So x equals tan of 25 times 15, right? So 15 times tan of what? 25. 15, 25. And that's going to give us 6.99. That's the length of the opposite. Okay. From 32, this is the opposite, this is the hypotenuse, this is the adjacent. So we want to use a function that uses adjacent and hypotenuse. That would be cosine. So cosine of 32 is adjacent over hypotenuse. Again, cross multiply. Very repetitive, right? So we're going to get 24 times cosine of 32, and that's going to give us 20.35. That's the length of x. I guess I'm doing all these problems. They're not that bad. So from angle x, this would be the adjacent, this would be the opposite, and this is the hypotenuse. So again, we want to use tan. Tangent of x, we want to find an angle. 12 over 15, because it's opposite of our adjacent, so x equals inverse tan 12 over 15. Let's see what that angle is. So we're going to go to 6 and 12 over 15. Enter, and that angle is 38.66. We want a side, we want the hypotenuse in this case. From angle 18, this is the opposite, this is the adjacent, so we're going to use cosine. So cosine of angle of 18 is the adjacent, 5.8, over the hypotenuse. If you cross multiply this, you're going to get h times cosine of 18 equals 5.8. Now we're going to divide both sides by cosine of 18. That goes away, and we're left with hypotenuse isolated. So 5.8 divided by cosine of 18. 5.8 divided by cosine of 18 degrees. And it gives us that the hypotenuse is 6.10. Okay. Right, moving along. 9, again, same thing. Angle 30, so this would be the opposite. Oops. Right, from angle 30, this would be the opposite. This would be the hypotenuse. This is adjacent. So we're not going to use the hypotenuse, so it's tangent. Tan equals tan of 30, equals the opposite over the adjacent, which is x, cross multiply. Tan 30, x times tan of 30 equals 20. Divide both sides by tan of 30. This simplifies to just x, and in your calculator you put 20 divided by tan of 20, and we get 54.95. Right? Number 10, again from angle 65, this is the opposite, this is the adjacent, this is the hypotenuse. We don't want anything that uses adjacent because we don't have anything about it, so we're going to use sine. So sine of angle 65 equals opposite over hypotenuse. So again, this one's easy. If you cross multiply, you get x equals sine of 65 times 17. So x equals 17 times second function sine of what? 65. Enter. We get 15.41. Round. Following questions ask you to solve the triangle. So you have to find x and y, or no, sorry, just x and y. This is the opposite of angle 70, and this is the hypotenuse. This is the adjacent. So it's up to you. I guess I'm going to have to do 2. So from angle 70, let's find y. So to find y, we're going to get tan of 70 is the opposite, which is y, over the adjacent, which is 36. Right, if you cross multiply, you get y equals tan of 70 times 36. 36 times tan of 70. And that's going to give us 98.91. That's the length here. Okay, now you want to find the hypotenuse. I'm going to use adjacent and hypotenuse. So for the hypotenuse, I'm going to use cosine. So cosine of angle 70 is the adjacent, which is 36, over the hypotenuse. Cross multiply equals 36. We're going to divide both sides by cosine of 70. And h equals something. So h equals 36 divided by cosine of 70 degrees. And that's going to give us 105.26. Right, so there's 2 things you have to find here. 12. Oh, we just want to find the angle. So for 12, let's see. The perspective of x, this is the opposite, this is the hypotenuse, this is adjacent, so we're going to use tangent. So tan of x equals opposite, 107 over 128. So x equals the inverse, right? 107 over 128, and that's going to give us, let's see, second function, 6. I'm going to enter 107 over 128. Enter. We're going to get 39.90 degrees. Okay. 13. Again, let's label the triangle first. This is the opposite. This is the hypotenuse. This is adjacent. Let's find the opposite first. So to find the opposite, we're going to use tan of 15. So tan of 15 equals the opposite, which is y over the adjacent, which is 48. So y equals tan of 15 times 48. Y equals 48 times tan of 15. It's going to give us 12.86. So this is 12.86. Right. And to find h, I'm going to use cosine. So cosine of angle 15 equals adjacent, which is 48, over the hypotenuse, which is x. Cross multiply. X times cosine of 15 equals 48. Divide both sides by cosine of 15. And x equals 48 divided by cosine of angle 15. And that's going to give us 49.69. Again, ooh, we need an angle here. That's different. So let's start with, actually, don't matter. Let's start with angle x. So from angle x, this is the hypotenuse. This would be the opposite, and this would be the adjacent from the perspective of x, right? Angle x. So to find angle x, we're going to use something that uses the opposite and the hypotenuse, so that would be sine. So let's write sine of angle x is the opposite, which is 36 over 66. Yes, that's easy. So x, right, x equals inverse sine 36 over 66. So 4 fraction 36 divided by 66. We're going to get that x equals 33.06. Now, if I know that this is 33.06 degrees, and I know that this is 90, well, to find angle y, we're just going to do 180 minus the 90 degree minus 33.06. 90 minus 33.06, and we get 56.94 degrees. Right? That's even easier than finding two sides. 15, unfortunately, is not angles. So based on 25, this is the opposite, this is the hypotenuse, this is the adjacent. So let's go for, doesn't really matter. Let's go for let's go for y. So side y, to find side y, we're going to use cosine. So cosine of 25 equals the adjacent, which is y, over the hypotenuse, which is 42. So y equals cosine of 25 times 42. Enter. So we get that y is 38.06. To find x, we're going to do sine of 25 degrees equals the opposite, which is x, over the hypotenuse, which we know. Cross multiply. Sine of 25. So 42 times sine of 45. We get 29.7. 16. This is the opposite, this is the adjacent, this is the hypotenuse. So let's go for y first. So it would be, again, cosine of 35, right? It's the adjacent, which is y, over the hypotenuse, which is 85. So if you cross multiply, okay, 35 times 85, y equals, so 85 times cosine 35, enter, we get 69.63. X, on the other hand, will be cosine of angle, sorry, not cosine, sine of angle 35, which is the opposite over the hypotenuse, 85. Cross multiply. Right, let me just change that to an x. X equals 85 times sine of 35. Oops. And we're going to get 48.75. Nice. Next two. All right. So now it's important for me that you draw the picture, right? Because I really think it helps. So let's draw the first one. Avery is at the top of the Eiffel Tower. So again, the tower. She's here. Okay. When looking out, she sees a Seine River. Here's the river. Right? And the angle of depression. So first thing we do, if she's on the top, her horizontal line is this, right? And then we're going to get, and then it says, when looking out, she sees a river at an angle of depression of 62 degrees. So, and then, oops, sorry. This angle here is 62 degrees. Okay, the height of the tower is 324. So this is 324 meters, which means this guy here, right, it's 324. So this is the information we have. What is the horizontal distance from the Eiffel Tower to the river? So we're looking for this guy right here. The horizontal distance from here to here. And I'll label that as x. So hypotenuse, we don't have. We have the opposite. And we're looking, instead of x, you know what? Let me write the adjacent. Right, so hypotenuse, we don't have anything. And we're looking for the adjacent. So this is definitely a tangent. So tangent of 62 equals opposite, which is 324 over the adjacent. Cross multiply, adjacent times tan of 62 equals 324. Divide both sides by tan of 62. And adjacent equals equals 324 divided by tan of 62. That's going to give us, that's the height. The tower is 172.27 meters. Okay. A surveyor standing 100 meters from a bridge. So there's a surveyor, and this is the bridge. Okay, so this distance right here, sorry about the drawing, that's 100 meters. She determines that the angle of elevation to the top of the bridge, so let me make this bridge a little bit higher. Right, so top of the bridge, right? Here's the bridge. So the angle of elevation to the top of the bridge is 35 degrees. Right, so there you go. This is 35 degrees. If her height is 2.5 meters tall, what is the height of the bridge? Oh, I'm going to have to redraw this. Right, so this is the person, and I know this is 2.5. Okay, and she's standing 100 meters from the bridge. I'm going to draw a bridge. She determines the angle of elevation to the top. So here's her horizontal line, right? Her line of sight. Okay, so that's And then we're going to draw an angle of elevation. Yeah. So that's 35 degrees. And this is 100. How tall is the bridge? And we're looking for this. So in this case, hang on a second. Make sure I can do this correctly. It would be, this is the hypotenuse, this is the opposite, and this is the adjacent, so we're going to use tangent. So tan is 35 equals opposite, which is over 100. So the opposite, which is the height of the bridge, equals tan 35 times 100. So that equals 100 times tan of 35, enter. So that's going to give us that the height of the bridge is 70.02 meters. Actually, plus her height, right? Plus her height, I think we have to add her height. Plus 2.5, it should give us 72.52 meters, right? Because we're adding her height there. I think. Give me a second. I think I have the answer somewhere here. Let me just take a look. Give me a second. No, I don't. 72.52. Give me a second. We'll leave a little star here and see if I can find the answer to that. Just imagining, because we have to add her height to this. Her height's 2.5 meters tall. Jeez, this woman's a giant, because I measure 1.78. What the heck? Anyways, we have to add her height, because that would make sense, right? Oh God, 2.5 meters. Made this question. From the top of a lighthouse, let me draw a lighthouse. The angle of depression to a buoy, so this is the water, and buoy is one of those floating things that I don't know how to draw, so there. Right, so this is the horizontal line, and the angle of depression is right here, so this is your angle of depression, 25 degrees. Let me erase this. Okay, so the top of the lighthouse, the lighthouse is 150 feet above sea level. So we can say that this is 150. is your 9 degrees, so this would be your hypotenuse, this would be your adjacent, this would be your opposite. Find the horizontal distance from the buoy to the lighthouse. So we want the adjacent. That's we have the horizontal distance. So we want to use something that has adjacent and opposite. So it would be that tan of 25 is opposite over adjacent. So adjacent times tan of 25, if you cross multiply, equals 150. Divide both sides by tan of 25. And we get that adjacent, the horizontal distance, 150 divided by tan of 25, enter, 321.68 meters away, horizontal. A jet takes off, so we have a jet here that takes off. A jet takes off, right? Let's take it. And travel 56 miles to achieve an altitude of 12.6. So here's an airplane. Runway, airplane, I'll draw it right now. Jet's taking off, right? It's going that way. So finally he reaches an altitude, right? So a height of 12.6 miles. So I'm gonna write that he's 12.6 miles above, right? What's the angle of elevation? So took off from the ground. Here's my horizontal line, so this is what we're looking for. He went 56 miles up, and by the time he was up, traveled 56 miles, he was an altitude of 12.6. So label the triangle. This is the adjacent, this is the opposite, and this would be the hypotenuse. So we're going to use sine. Sine of x equals opposite, which is 12.6, over the hypotenuse, which is 56. What is the angle that has that particular ratio? Well, x equals inverse sine of 12.6 over 56. X equals, let's figure that out. 12.6 over 56, enter, angle is 13 degrees. Okay. All right, so now we're going to move on. Determine if there's 1, 2, or no triangle. Remember what the cases are. So I'll write it over here. When there's one triangle, A is going to be greater than B, and I'll draw the triangle out in a second. And A is going to be greater than the height. Okay, little a, I should say. That's one triangle. When there's no triangles, right, A is going to be less than B, and A is going to be less than the height. And when there's two triangles, we're going to have that A less than B, but obviously A is greater than the height. So let me draw the information that we have. So we're going to have, right here is the base of the triangle, right? And let me draw the triangle. This is angle A, this is A, and this is B, this is little b, and then this is little a, right? So I'm not drawing the rest of A because I still don't know if I can make a triangle. So, and there's obviously the height that you have to figure out. And then remember how to find the height. Height is going to be, let me write over here in orange. Find the height, we're going to use height equals b, little b, sine of this angle. But this is what you're going to be given. So you're going to be given this, you're going to be given this, and you're going to be given the angle. All right, side, and an angle. All right, so now to determine if you can make a triangle, well, let's look at the first one. Let me draw the first one. So first one says, here's A, here's the base, Right, and this is quite a big angle. It's 110, but this is 110 degrees. Got to draw a little bigger. Little a is this guy right here, right? Which is, this would be little a right here, right? This would be little a. This would be little b. Now I drew little a all the way out just so you can see it, but I'm not going to draw it out because I don't know if I can make a triangle 2 or 3. So I need to find this height here. And to find the height is going to be b, little b, which we do have right here, 100 times sine of 110 degrees. Let's find out the height. The height is 100 times sine of 110. Enter. So it says that the height is 93.94. So let's look at the conditions. Is A, and for number 19, is A is greater than B? Yes. A is greater than B. Check. And is A greater than the height? 93.94. And A is greater than the height, 93.94. So if both of those conditions meet, then we have one triangle. So for the 19, it's one triangle. Okay. Let's try 20. If I can draw a better triangle. Again, 110 degrees. Call that A. This is 110. And this is 200. Right, and little a, which I'll put in green, I'll draw the whole thing, is 125. Let's find the height of the triangle first of all. So height equals 200, or little b, times sine of 110. And we get 200 times sine of 110. And we get 100, that the height is 187.94. So, in this case, A is A greater than B? A is 125. Is that, and compare that to 200. A is this is sorry guys. Let me write it over here. Make it better. So A is 200. Sorry, A is 125. B is 200. So A is less than B. And let me write that the height is 187. And A is less than the height. So A is less than B and A is less than height. So what situation we have? We have that it's not a triangle. Okay. Let's do C. So here's the base. Here's 76 degrees. Here's angle A. Little b is 20. Right here, b is 20. And then little a, which I'm just going to put it over here, is 18. Right. Let's get the height, which is 20, little b, times sine of 76. And the height is 20 times sine of 76, which is 19.41. So let me write this down. A equals 18, B equals 20, and the height equals 19.41. So A is less than 20, and A is less than the height as well. So this is also, 21 is also a no triangle. Okay. find the area. Okay. And then we had this. One second. Wish I had the answers. Okay, so to find the area, you're always going to have this situation here, where you're going to have two sides, right, and the angle. And that's just enough for you to find the area. So in this case, we're going to have the angle, which is 120. Let's call that C. And then, depending on where you put A or B, well, if this is C, little c would be here, right? If this is A, for example, little a would be this guy, and if this is angle B, this would be little b. So this is what you have, right? So in all the situations here where you don't have the height, you're going to have two sides and the angle in between. So to find the area, right, we're going to do half of A times B, okay, and then sine of this angle, 120 degrees. We're going to repeat the same for both. You're always going to have the angle and the two adjacent sides. So put that in the calculator. So sorry, half of, in this case, for number 29, half times 4 times 6 times sine of 120. So I'm going to simplify this to 2 and then just write 12 times sine of 120. And the area of this particular triangle for number 29, the area is 10.39 units squared, whatever it is. For the second one, again, you can just draw it again, same thing, same way. Right? You have an angle, let's call that B, 130. If that's angle B, then the adjacent sides would be, one's A, it's going to be 62, and the other one's little c is going to be 20. Right, and here's your triangle. Find the area. The area is going to be half of the two sides, in this case 62 and 20, times the sine of the angle, 130. So you can simplify that. Let's just make that. And then 62 times 10 is 620 times sine of what? 130. Enter. So the area of that particular triangle is 474.95 units squared. 31, again, it's 45 degrees, so it's base, you're about 45, not 45 degrees, 43, 45. 43 degrees and 45, is it minutes? B is this, and then C would be the one here at the bottom. So again, half of 57 times 85 times sine of 43, 45. And put that in your calculator. Times 57 times 85 times sine of, what is that number? $1,666 units squared. Okay. Oh my god. Alright, so these ones are asking you to use lost signs to solve a triangle. Maybe I won't do all of them. Maybe I'll do two. Here, let's do the first one here, number 1. It's all labeled for us, so we can say 20, a little a sine of 30 equals little b sine of 45, which equals little c over sine of, and again, we can find this angle, remember? So we're going to do 180 minus 35, sorry, 180 minus 30 minus 45, and it's going to give us 105. This is angle 105. So I'm going to write 105. All right, so now you can use, going to have to do two proportions, these two and maybe these two later. So let's do the first one. So B sine of 30 equals 20 sine of 45. We're going to divide both sides by sine of 30. Right, and B is going to give us that numbers of 20 times second function 45. 20 times sine of 45 over sine of 30. Enter, so that's going to give us 28.28. So B, 28.28. C, little c, again, I'm going to use the first and the third ratio, so 20 sine of 30 equals little c sine of 105. Cross multiply, c sine of 30 equals 20 sine of 105, sorry, times sine of 105. Divide both sides by sine of 30. And little c equals whatever that gives us. So 20 times sine of 105 divided by sine of 30. 30 or 35? 30. Shoot. Enter. And we get 38 and 63. 64. And that's it, right? It's pretty easy here. So again, 105, 145, angle A would be 35, right? Because they have to add up to 180. So now you can set up your sine. So A sine of 35 equals B sine of 40, which equals little c, which is 20, over sine of 105. Okay, so again, rinse and repeat, right? We're going to use these two to find little b, and then these two to find little a. I'm not going to do that problem. There's nothing there. Again, for number 3, we can find angle C, right? You can find this angle by subtracting 180 minus 25 minus 35. In number 4, you can again find angle A by doing 180 minus 35 minus 10. Set up a proportion. Not going to do those. 5, 6, 7. Same thing. Give me a second, see if I can at least give you guys the answers to those. Some of I took it from. Yes. Not this one, sorry. Also not this one. Maybe this one. No, not this page either, sorry. No. Maybe this page. Anyways, you shouldn't have too much difficulty in doing those. Let me go to log cosines. Sorry guys, I can't find it. If I do, I'll leave it there tomorrow for you guys. the law cosines. Let's do number. Let me take this guy out. Actually, I can do this. And it's the letter A. So this is the one I'm doing. Right. So if you want, I mean, you know, the good thing here is that they didn't label anything. So remember, it's always going to be, well, the angle that's given to you, right? The opposite side that in this case you don't want to. I'm trying to find an easy way of saying this. Let's label this A. Let's call this B. Let's call this C. This would be little c, little a, little b. I think it's easier if I do that. So it's going to be c squared equals a squared plus b squared minus 2 times ab cosine of angle c. Okay, so in this case, c is what I don't know. A squared is 22 squared. B is 17 squared. Then we're going to do 2 times 22 times 17 cosine, and I have that angle. It's 42 degrees. You can apparently enter all that in your calculator at once. So 22 squared minus 17 squared minus 2 times 22 times 17 times cosine. Okay, 42. And I did something wrong. Oh, sorry. 22 squared plus 17 squared, that makes no sense, minus 2 times 22 times 17 times cosine of angle 42, enter. So we're going to get that's c squared, and in my calculator it's 217.127 dot dot dot. We're going to take the square root of that. Right? And our final answer is going to be that c is about approx 14.74 units. Okay. I'll do one more where they're asking for the angle. So look at this one. So again, I'll label this the same way as they did before. So that's C. This is big A, big B. So this is little c. This is little b, and little a. Set up the same way. C squared, little c squared equals little a squared plus little b squared minus 2ab times cosine of angle c, which I don't have. So c, 35 squared, a squared, what's 8? 47 squared plus 39 squared minus 2 times 39 times 47 cosine of angle c. We're going to have to use the inverse of cosine, right? Find the angle. So let's simplify this as best as we can. So this is 1,225 equals 47 squared, which is 2,209, plus 39 squared, which equals 1,521. We're going to add those two, minus 2 times 39 times 47, minus 2,145 cosine of c. Let's combine these two. So 2209 plus 1521. Enter is 3,730 minus, again, and then we're going to subtract 3,730 from both sides. I'm going to be left with negative 2,505 equals negative 2,145, because this goes away, cosine of c. Now divide both sides by 2145. That's going to give us a positive number. And I'm just going to leave it as a fraction. I'm not even going to divide. So we actually get, cosine of c equals, let me just leave it as it is, positive, by the way. And now we're going to take the inverse. So c, angle c, is inverse cosine. And you put 2505 over 2145, and we're going to get the angle. Second function, number 4, 5 in your calculator, fraction 2505 over 2145. Enter. What the heck? Second function. Five over 2145. Did I do something wrong? Give me a second. Let's give me a domain error. 35 squared. Plus 47 squared. Plus 49 squared. Let me just run over my numbers again. That's okay. That's okay. That's also okay. 2 times 39 times 47. Oh, shoot. Here's my mistake. This should be 3666. Okay, I don't know where I got 2145. This is going to be 3666. And then, all right. Okay, now let's enter that in the calculator again. So we're going to get second function, inverse cosine 5, 2505 over 3666. And we get that angle C is 46.9. All right. That one has, you really have to be comfortable, right, with working your equation, knowing your steps in order to do that, which is nice, right? Yes, because you get to practice all that. Let's see. Yeah, that's it. I'm going to end it here. And again, if I can find, if I can find it, then the answers to those, I'll come back and I'll post it at the end. Okay, but that should be a good review.